Hello, welcome back, everyone. It's wonderful to have you back after our break. We have our panel here now ready to go. And so we're just going to kick this off. I'm getting a little bit of interference in the background, so I'm not sure where that's coming from. If you are not speaking at the moment or about to speak, maybe just mute yourself. Our panel discussion is going to be on future networks, blockchain in future networks. So we've got a great panel. I'm going to introduce our panel chair, Doug Junor. Doug is the managing director at 4Rev. He's been driving business transformation across North America for over 35 years. Clients and audiences alike have praised Doug for his insightful thoughts around emerging innovations that can disrupt the status quo of any organization. And certainly blockchain is one of those disruptive technologies. His time in past leadership roles, from director of channel development to chief business officer with various industry leading and award-winning companies, has made Doug a highly valued advisor. He enjoys using his real-world experience to help a broad range of entrepreneurial startups, public sector entities, and established enterprise corporations implement a sustainable business transformation strategy. As testament to Doug's experience, Doug has developed and delivered programs at the SAIT school, so that's the Southern Alberta Institute of Technology, School of Advanced Digital Technology, including digital strategy and leadership and transformational leadership executives. So Doug, welcome. Thank you for participating, leading this panel discussion. Over to you.
Thanks, Vicky. When I was approached to do this, I was pretty excited. One of the things that in that introduction that Vicky didn't point out was that the first 2.5 decades of my career were in the telecom and the networking world. So I was really excited to see, where it's going with respect to blockchain, and we've got this amazing panel in front of us. So what we're going to do is I'm just going to do a quick introduction of each of the panelists. And then the panelists will have an opportunity to give us a little bit of a presentation in terms of their view of the world with respect to blockchain and networks. And then hopefully we get questions from the attendees, but if not, I've got some questions lined up so we can have a good discussion after. So with that, just as I said, I'll do a brief introduction and I'll let each of the panelists maybe dive in a little bit more to their experience. But first of all, we have Ben Smeets, who's a senior expert on trusted computing at Ericsson, as well as a full professor at Lund University in Sweden. And Ben is joining us from Sweden today. So thanks for joining us, Ben. We have Neel Dayal, who's the senior director of innovation and partnerships at Rogers Communications. Thanks, Neel. We've got Raouf Boutaba, who is a university chair professor and the director of the David R. Cheriton School of Computer Science at the University of Waterloo. And I know Raouf is actually dialing in from Europe today as well. So we've got, appreciate making the effort to join us. And then finally, we've got Wen Tong, who's the chief technology officer and chief scientist for 5G with Huawei Wireless, joining us today. So quite an amazing panel of expertise here. I'm really looking forward to each of them. And as we sort of behind the scenes, we sort of rolled the dice in terms of order, and Neel gets to go first. So I'll hand it over to you, Neel, to share your presentation.
Great, thanks, Doug. And it's great to be here on this really amazing panel. I know obviously Dr. Boutaba well, and so it's always a privilege to be sharing a meeting with him, and nice to be on the same panel with Ben and Wen as well. So yeah, I'm just going to make sure that my screen works here. So let me know if you could, Doug, if something shows up.
We're good. We got your screen there, or your slides there.
Okay, great. So I'm going to kick things off. So my name is Neel Dayal, as Doug pointed out. I work for Rogers, so I represent sort of the service provider point of view on this. I'm going to kick the presentation off in maybe a bit of a different direction. So I think we're going to get into some of the specifics and some of the technical aspects of blockchain, and happy to go into some of that in further detail. But I also wanted to provide a bit of a background in terms of how we think about blockchain and in particular with respect to future networks. So within the organization, I sit within the technology office. I support our entire enterprise around different emerging technologies. One of the primary technologies that we've been very focused on recently has been on 5G. And we've been able to collaborate with folks like Dr. Boutaba on some very interesting research topics in that domain. Also working in IoT as well and understanding both the applications of 5G and as well as 4G and other IoT capabilities. And so for us, what's important for us is really kind of having a common approach to the technology and how we approach that, whether it's 5G, whether it's blockchain, et cetera. Some of the things we like to think about when we're considering emerging technologies are what could it be used for? Right, and what's the impact this is going to have on the organization? I think there's a lot of opportunity for us to get distracted very quickly on different technologies and different capabilities. And so we're always thinking about what could it be used for? How should we go about it? Blockchain is really interesting because it's a very new technology. And historically, we haven't had a lot of experience with this technology. Very different than networking. Well, yes, we may not have experience with 5G, but we have a lot of experience with 4G and 3G and 2G, et cetera. And so therefore, there's probably some expertise that we can augment or build on. Blockchain is something very new. And one of the reasons in my title, which is Innovation and Partnerships, we have both of those things is because in some of these areas, we do rely upon different industry and academic partners for helping us get knowledgeable in a particular domain. So what are the implications? How would we research this? What's the widespread applicability? All of these are questions that we really think about as we start to move down a particular technology. And then finally, what are the benefits? What are some of the challenges? And we've seen some start and stops with blockchain in the service provider industry. And I think back in 2018, I started a blockchain community within Rogers where a lot of technologies were being developed and use cases were being developed on Hyperledger as an example. And, that's been a very sort of interesting thing to watch. And we've seen some of the scalability challenges that as a result of high gas fees on Ethereum or just slow processing capabilities or the volatility around some of these cryptocurrencies, all of these things feed into our understanding of the technology where we're able to do that cost benefit trade-off. So I'm just going to move to the next slide. So the first thing that we always do when we're thinking about new technologies, when we've done some initial sort of assessment, is think about the use cases. And typically for us, we look at both the business and the network side of use cases. We also like to follow, I think what most people are fairly familiar with is the sort of the technology readiness model. I think NASA was the ones that sort of initially adopted it, but I think it's been adopted pretty worldwide, and in particular Canada. But then ICET has also categorized these 9 stages, which are really around the maturity. And so that continues to be the way we're approaching blockchain. And eventually, the idea is you start with some early research and you build prototypes and do proof of concepts, and eventually you have a commercial capability that you can deploy. We feel we're very early. We're at like 1G equivalent from if you were to compare where we are on the networking side, we're at like 1G from a blockchain perspective. And so we're just really kind of in the early stages of even deploying and testing some of the technologies. But some of the use cases that we have been considering are around identity, settlements, fraud, and payments. And those are maybe some of the more business type of use cases. And then we also have a number of network and service use cases, which the things like SLA monitoring, smart contracts, security around 5G and IoT, and fraud prevention and theft as well. So those are sort of the two categories of types of use cases that we start to think about. I'll go to the next slide. Oops. So what's interesting for us is, the next phase for us is really about formulating that plan. And one of the things that we've really taken to at Rogers is to use design thinking. And that, usually at a tech discussion or a tech panel, that doesn't always resonate. But for us, I think what's important when we think about technologies is really understanding the problem space. And therefore, that's why we use a real sort of robust design thinking process where we initially park the technology and really validate that the area that we're going after is a meaningful opportunity. Once we do that, then we have a better sense of the problem space and we can do a better match of the technology. And this is, again, sort of where we've been kind of focusing a lot of our time and energy. And for us, some of the next steps, once we've identified that problem space that we want to go after, is really about determining the right partners. Who do we want to work with? And today in blockchain, it's a very crowded space. I think for us as an organization, our initial engagements in this space have been more on the academic side in working with our great partners at UBC, Waterloo, Ryerson in those domains. There's still a lot of questions that I don't think we're in a position to make big, large bets on. Who would be the infrastructure provider, as an example, around blockchain? We see lots of things, challenges in the market around when we'll see Ethereum 2.0 roll out. We see a lot of volatility and stability challenges around things like Solana and outages. And as a service provider, we are very customer centric, very focused on making sure that we're able to support our customers in the critical businesses that they need and critical activities. And so we're always constantly evaluating the maturity of some of these infrastructure providers. And I think that's why the academic and research partnerships are really helpful in helping us understand that landscape. And then finally, just what does N+1 look like? So what do we need to have in place to be able to support these technologies? And again, because of the fact that many of these technologies are emerging, we need to think about hiring and upskilling around some of these activities. So just in terms of potential use cases, again, we're a regulated industry. I think the one thing that we've been able to do effectively in this country is make sure that we have the trust of our customers, and we want to maintain that. We think blockchain is obviously going to be a real benefit and boost to that. And so some of the use cases that we have identified are around security, identity, roaming, phone theft prevention, and payments. And I think those are probably some of the big ones that are of interest to us. And then finally, I'll just move to the final slide. Again, we always got to go back to why would we do this? What's the benefits? And from our perspective, we think that benefits that we're really kind of focused on are improving the customer experience, increasing the trust between the customer and the telecom provider. Obviously, there's a cost benefit opportunity. If you think about roaming and settlements as an example, there's always a benefit to being able to do that reconciliation and settlement much quicker. And we also think that it's, as Rogers always being the first in many areas, first in for 1G, 2G, 3G, 4G, 5G, we pride ourselves on being the first in being innovative. And so we think there's, again, another opportunity to continue to augment our brand and our commitment to being an innovator in this space. So, just final words. As a company, we're going to continue to work on this technology. We're working really closely with research organizations and individuals. We've kicked off a really interesting blockchain project at UBC. So we'll continue to work with academia, and we'll also work with some of the incubators, like our partners at Communitech, to really understand that ecosystem. For us, it's a really long-term strategy, but what we want to make sure is when we do deploy these technologies, at scale. They need to be scalable, they need to be reliable, and they need to be robust enough for our customers. So that's it for me, Doug, and happy to hand it over.
Thanks, Neel. Appreciate it. It's interesting. I like your comment about a net new technology as opposed to the evolution of something that already exists. So that's an interesting angle there. So thanks, Neel. Next up, we have Wen. Over to you, Wen.
Yeah. Okay. It's slow. My share button is still not enabled, like last time.
Vicky, can you re-enable Wen's share button?
Hi, yeah, I will. Okay, I'm gonna remove you. I'm gonna make you co-host Wen.
Yeah, one time. Yeah.
Again, just give me a second here. We'll just withdraw co-host, and then I'll reissue you co-host privileges that seemed to work last time. So whoops, on a second. Okay, there you go. Okay. Try that.
One more time. No. Yeah, somehow the share button is in dark gray.
Okay.
See.
Yeah,
So maybe what we'll do is let's move on to Raouf. Vicky, if you can sort of work behind the scenes to get Wen configured as the co-host, and then we'll come back to you, Wen. Raouf, you ready to go?
All right. Okay. They share my screen.
I can see it. Yeah, we're good to go.
All right. I just need this. Okay. Okay. So in my opinion, the main added value that blockchains bring to networking is network security. So I'm going to focus my position statement on the potential of public blockchains, in particular as enablers for self-securing network protocols. And along the way, I will discuss some of the misconceptions surrounding the use of blockchains for various networked applications. Let me first discuss how pre-blockchain security protocols move around or transfer trust to other spheres rather than create secure protocols. A simple example to illustrate is that of, say, Alice wanting to email Bob over an insecure network. In this case, Alice trusts a PGP key server to tell her Bob's public key. She also trusts Bob not to leak the contents of the conversation, not to have malware on his phone, etc., etc. There are many other similar examples, but basically the idea is that security always comes down to some sort of root of trust outside the network protocol, and other areas as well. Trust the bank, trust the payment channel, trust the e-commerce site, and so on and so forth. So what is different about blockchains? Blockchains are arguably the first self-secured protocols. What does this mean? It means that the blockchain does not transfer trust from an existing root of trust into a wider sphere. Instead, it incentivizes and generates its own root of trust. Take Bitcoin as an example. Yes, you do need to trust 51% of the miners, but the interesting thing is that the Bitcoin protocol pays the miners to be honest. So we only need to trust that they are rational. So Bitcoin's original insight was that by bundling a cryptocurrency and designing mining incentives, we can make sure that the participants actually follow the protocol without any external root of trust. The protocol is its own root of trust. This really is unique. By combining incentives and protocols, you can engineer a protocol so that it can be assumed to be trustworthy because it pays to do so. I think that this is the actual central point of blockchain that differentiates blockchains from other technologies. This is why we have blockchains, I think, in the first place. It is not exactly things like decentralization or transparency. There are other things that are decentralized too. For example, DHTs are decentralized. There are other things that are transparent too. For example, key transparency is an important transparency protocol for TLS. I think the main contribution of public blockchains is that instead of transferring trust from an existing basis, it uses economics to generate trust. And this is what makes blockchain special, in my opinion. This also means that blockchains that don't have this property are kind of pointless. Private blockchains, for example, and even consortium blockchains generally lack this property, though they are, as you know, somewhat decentralized. So what can we learn from this? A lot of people say a lot of things about blockchains, but what is distinct about blockchains is the self-securing property I mentioned. So we learned, first of all, that incentive design is critical. If you are making a blockchain or building something on the blockchain, you need to make sure that incentives actually build up the security system. And second of all, it also means that private blockchains are categorically less interesting. They may have some use cases, but they don't have the key innovation of blockchains, which is security-based or self-incentivizing trust. They are still based on trusting certain trust parties. And finally, I think that security protocols or just network security systems that extend this kind of self-securing blockchain security are under-researched, or there's at least a lot of research that is needed there. In traditional protocols, we start with trusted parties and then extend from them. So what about a protocol that starts with a self-securing system and extends to a bigger self-securing system? For example, in my group at Waterloo, we built a secure naming system as well as a secure software update system that built on top of Bitcoin security. So you start basically with Bitcoin, then you build these other bigger things, transferring the trust of Bitcoin into something bigger. So other ideas include things like strong cyber-resistant DHTs, for example. And beyond blockchain, another lesson that blockchain teaches us is that incentives are really important. And it is possible to build protocols that incentivize their security properties instead of merely assuming them. So I think that people should be thinking more about this. And it shouldn't be just blockchains. We should be thinking about this when we design peer-to-peer networks or design any kind of secure system for that matter. We should think about the incentives for why the security assumptions are true or will hold true. And I think that was my last slide. So back to you, Doug.
Great, thanks, Raouf. I think we're still having some trouble with Wen's connection there. Wen, if you could email me I'm going to send you an email. If you could email your presentation, I'll try and throw it up on my side for you. And in the meantime, Ben, if we could get you to step up and give us your presentation. We're good. I see it there. You're muted there still, Ben.
Yeah, can you see me and hear me?
We're good to go, yeah.
Okay. So thanks for giving me the opportunity to talk a little bit about my view on what ledgers and blockchains can be used in the mobile networks. And like Doug said, I'm working at Lund University and also at Ericsson Research. And yeah, it's always a little bit difficult, let's say, when talking about networks, let's say, to what are we talking about. And so I give you a little bit, let's say, how I see, let's say, the 5G and what is important from, let's say, my security perspective, and talk about, let's say, some particularly useful things where I can see blockchains become, I think, useful, not only technical, but also, let's say, business-wise. And I think we see already some common thinking about this, like the roaming case. But I also see many challenges. I think we at Ericsson, we did some work, let's say, on the roaming case already a couple of years ago back. And while technically I think we see the potential, I think we have not reached the maturity, let's say, to let's say go really there. And it could be, let's say, that it will take some years of industry and academic work to go there. So if you understand, let's say, the network as we talk today, it's a 5G network. It has a radio part and it has a core part. And mainly, let's say, the core part is very interesting because it's using, let's say, what is called a service-based architecture. And in that architecture, one has brought in a feature called slicing, where you could think of, let's say, if you want to have a particular service, maybe two types of services, like a factory or the ordinary broadband, then you can partition, let's say, the functions in the network according to where they work on, let's say, on the broadband or the factory or both. And that's a very nice feature. But also when you are thinking, let's say, how you want to interact between those slices, then it's not so easy. And to get an idea, let's say, why we are interesting, let's say, to look at these things like authentication and authorization comes from how it internally works. Let's say if we have two network functions that want to communicate, then let's say this network function 1 wants to communicate to network function 2, and to do that, let's say it must discover this network function 2, and there is a whole solution built on let's say identities that are important to do those rather familiar steps, like based on OAuth, getting a token in step 3 to consume that service. But it means that you have to have identities in that infrastructure. Today, let's say, it's very much based on PKI, but we could actually think of blockchain type of identities that could have other features to do that. But then, of course, you have to think about performance. It has to go very quickly. In general, let's say, and then what other types of use cases we can think of and it was already mentioned, is roaming case where normally, let's say, between two types of networks, there is a clearinghouse or a third party that is helping, let's say, in the billing, in the handling of the roaming scenarios. And normally, let's say, these third parties are quite expensive. And you could think of that you replace this with a kind of smart contract-based system. And we played around the list at Ericsson and showed that it technically works, let's say, at a small scale. But like it was said earlier, let's say, you must scale this up to let's say, millions of users and connections that has to be handled. Another use case that we see, okay, we have, for example, in the slicing scenario, a factory that has a slice of a network, but the devices in that factory has also to get contact in the mobile broadband slice. How you govern the trust between that, and a blockchain enabled feature could here help, but that has not really been, let's say, explored in detail, and how that would be integrated in the technical, let's say, features of the 5G system to make that possible. Other use cases, let's say, that a little bit more at a distance are, of course, edge compute. And interesting, let's say, the edge compute is something that is being standardized now. So it's really, let's say, an opportunity to do something if you want to bring. But in standardization, when it's rather conservative. So even if you think it's possible to do blockchain technology here, the standard will probably not adopt it if it's not mature enough. Another thing is, of course, a little bit also in connection to services is consent handling. So operators and also edge compute, we can think of users using services and the networks gathering information. So will that be done, let's say, in a way that is compliant to GDPR? So there must be a user consent. And blockchains could help in that managing of those consents. Another thing, and a little bit back to this authentication, are these self-sovereign identities, which could be in the future be very nice, but I think today it would be a hard sell in the standardization to get this in. But from a research perspective, I think that would be very interesting. Let's say if people start working on that, how to make this possible, and to integrate it in the network. There are a lot of challenges, I think, in the networks. It's especially the public networks, they are highly regulated. So it's not only, let's say, something that, let's say, vendors like Ericsson and operators sort of play a home, but it's also the regulators that come into play. Actually, it may make it interesting to use, let's say, smart contracts. But also, let's say, these solutions must have a governance structure that must be acceptable, let's say, by the regulators. Otherwise, it would exclude, let's say, certain solutions. And then if you want to deeply integrate the blockchain, let's say, into the functions, then you run into performance issues. And there, I think we need, let's say, the academics and the industry work together, because the mobile networks, they are technically quite, let's say, tricky. There are a lot of protocols, and we cannot redo it. So that you have to integrate it in what exists, and so you must understand the use cases, and the academic, let's say, must sort of look into this problem, and maybe the challenge is there that some of those problems that we have to solve are maybe not good, let's say, PhD problems. So they are very advanced engineering, but maybe not, let's say, interesting enough for a scientific publication. So there's a challenge there as well. So let me stop there.
Great. Thanks, Ben. I got your presentation here, so I'm going to share it from my screen, and then if you can just let me know when you want me to advance, okay. We'll do it that way. So let's make sure that I can get this up here before we. Everybody see that?
Yep.
All right.
Thank you,
over
Doc.
to you, Wen.
Yeah, thank you, Doc. My panel presentation, I would like to focus on the blockchain for 6G. And this is a clean slate, of course, and then there's open problem and the challenge we have. So I want to discuss a little bit on that. Next page. So first of all, yeah, first of all, 6G is not a upgrade of 5G, and 6G is not for smartphone. 6G is a platform for connectivity, for computing, for sensing, and for AI. However, the challenge we have is that to make 6G a platform for security, for resilience, and for trust, these are the one of the key, or if it is not the most key challenge for 6G. So the second challenge is that much more devices will be enabled by 6G for not only consumer service, but for all the businesses. The diverse of a device type in this chart shows that the span of a 6G service will touch almost all the microelectronics devices, if not all of them. For example, 6 billion of smartphones and wearables, 2 billion cars and consumer robots, almost 1 trillion sensors and a billion servers. So these are the scale. The latency for all these type of devices are very stringent. Imagine if we put all these devices on the blockchain, the simple Nakamoto system will not scale. It's just because the throughputs were for the blockchain as we see today is about 7 transactions per second. The confirmation latency is 4 hours. So this is the first challenge is the scalability. So next chart. So in this sense, today's wireless networking model is that the operator and the subscriber are assumed to be trustworthy, which is built on the consumer contract, and the operator has the sole responsibility to maintain the integrity. So as the network evolve and the business become more complex, starting from 5G, now as Ben was talking, especially the geopolitics has a factor. In 6G, we can consider the trustworthiness is not a third-party based, but rather than based on massive distributed blockchain-like technology. The vision, for 6G trustworthiness is to re-architect the 6G network. So we would like to put every operation, like every activity, every protocol step, even every data transaction onto the blockchain. So that's the wish, and that every action is traceable and is auditable, and yet it's anonymous and privacy are guaranteed. So here we have two technical issues or challenge. One is to need provision sufficient some network throughput for running the blockchain communications, and to meet the blockchain delay throughput requirement. And the second is lower latency, such that we can apply the blockchain to the most critical, or almost all the details in the network operation. Next, so the design principle for blockchain is still decentralized. It's not, but it could be a membership based. It's a strong authenticity and integrity protection. For example, it's a consensus based, and can be proof of work and even proof of trust. I will talk a little later. and it's an anomalous privacy. Attack is traceable based on the ledger. The security risk can be identified with a proof of trust. And some other protocol is, that gossip simple protocol can be used through without the extra needed interfaces design. This is the simple way. Maybe we should design new interface as well. And we may need to reserve bandwidth for blockchain, as I mentioned. So coexist with centralized trust system as we have today. Because of many usage scenarios. So in this area, we have some interesting work such as a Prism that can have a better scalability, although the work we need to do much faster the latency, much smaller latency is required. And to evaluate some of the network size in the country, like Canada or Europe, the scalability of all the the ledger, distributed ledger, and the computing is a good news. Is still linear growth in the architecture like Prism. So this is a one area that we need to have a big engineering work to do if we want to do a blockchain network wide. Next chart. So the other aspect is how to incorporate trust. To incorporate trust for 6G network is a new architecture problem. The current blockchain design doesn't capture all the trust issues. So the 6G blockchain is like distributed ledger the concept can be incorporated into the trust model. That we need to figure out some way to quantitatively calculate the trust. And the DLT can provide a measurement on the trust and the cooperativeness or defectiveness among these network elements can be measured. And then the communications are manifested in the DLT or distributed ledger. Which provide the assessment of this trust as well. So there will be transactions between the trust values. So the trust can be a value or even an incentive for the people to run the to make sure to gain the benefit of being trusted on the network. Next page. Then how to design the incentive scheme to the trust in the blockchain, and how to quantitatively measure the trust for the future networks. So this is, however, I just give you two quick example for the computing and the measure of the trust and related incentives, because trust is still not a very scientific term that can be quantitatively. So this is one attempt. For example, this conventional wisdom is saying that the trust takes years to build, but second to break, and forever to repair. So in that case, when we have all these state machines for this trust computing in the big network, so we can put on this type of weighting function so this effect can be computed as a weighted trust sequence. So in the typical case, we can model this as a sigma function with a saturation and maximum value, and then we assign degree of trust and value as a mu, and then the event of a trust violation, we apply steep penalty function to the trust to the minimal, and then takes long time to grow as a different parameter of a signal function. So the last example, next page, is and more subtle, that someone doesn't take away anything, although they could, and that means they trust you, and people feel it is a trust. So in this case, and it's someone that gives something, although they don't need to give you because they have a more faith or trust in you. So this type of a thing, let me show another example. Probably we can measure in can be computed as trust in the probabilistic expectation of a prior knowledge, or the expectation of some bigger than a threshold. So for the probability of distribution of trust value of T, we can compute the cumulative value for the trust T and compare to a preset threshold. If the passing the threshold, and we assign the penalty. So that means there's many work need to be done. How to come out the measurement of trust as an incentive. So incentive is critical if all this blockchain technology without the incentive, there was very difficult to motivate people to use this network, this technology effectively. That's my talks. Thank you.
All right, thanks a lot. Thanks a lot, Wen. I see that we've actually got a couple of questions going on in the chat here, so I'll just read those out, and maybe if Ben or Raouf want to expand on it. But to Ben there, does it make sense to also use a permissioned ledger between multiple network providers?
Yeah, I guess it could, and then maybe let's say that's the way one start. Let's say that the for maybe governance reasons, let's say one doesn't want to go, let's say, with the public ones, so I guess, let's say, to bring this technology, you could also think that you get experience, you get acceptance, and maybe this permission blockchains could be a way to gain that experience. Like I said, the telco world is a little bit conservative and sort of accept, especially, let's say, in the GSMA, in the interconnect, let's say, one is sort of very careful to adopt new technologies. And the permission bonds, let's say, are maybe easier to digest, let's say, in that infrastructure.
Neel, I don't know if you want to add anything to that from the network providers lens.
No, not really. I mean, I think that Ben sort of captured it. I agree that that's probably a good place to start building some of that trust. I guess it goes back to even some of the things that Wen was talking about around performance, right? And I think Wen quoted 7 transactions per second or something like that. That's not gonna be satisfactory. I know there's some new blockchains that are providing better performance, but they're done not through proof of work, they're done through proof of stake type of models. So
right,
I mean, that's a whole another piece that needs to be researched on what model is going to work best for service providers. I don't think we have an answer on that right now. So,
Wen, did you want to jump in there?
Yeah, so I guess the permission-based model probably is the easy entry for the public network, because otherwise computational is too expensive, and the latency won't be satisfied.
Well, it diminishes the Yeah, it diminishes the value prop of 5G
Right.
or 6G.
Right.
Yeah.
Right?
Yeah. But on top of that, if technology like Prism or sharding and all this, that's a way to speed up, but it's not sufficient yet.
And I don't know, Raouf, if you wanted to comment on that, and then we'll jump into the next question that was directed at you.
Yeah, not much to add. I'm not, as you could have seen from my presentation, I'm not a big fan of permissioned blockchains. I think, I think they are dying anyway. And but there are a few use cases that justify their existence, and I think that's one of them. You know, when you have different administrative authorities, you know, trying to work together, that would be one case where this make a little bit of sense. But in general, I think I don't really. I'm not a big believer of private or permissioned blockchains. But that's my view.
So the next question is directed at you, Raouf, which is if the naming service only based on incentives, I believe that is or a combination of crypto and incentives.
Yeah, I think I can only elaborate on the smiley face. I think the answer is yes, is a combination of both. I think because Ray is asking the question, yes, crypto is everywhere, Ray.
I know when you had mentioned incentives in your presentation, I don't know if you want to weigh in on that one or not.
Yeah, so the incentive is especially in this telecom network. What is the incentive that people you know, motivated to prove their trustworthy or you know, or the operation that they want to put on the blockchain, so they can brand them as a golden trusted network. So that's the part. There may be the motivation, but it's still missing that how to compute quantitatively this thing into the blockchain. Especially the trustworthy is much more subjective as of today. So that's needed some work, you know, to capture the thing in the quantitative manner.
Neel or Ben, did you want to weigh in this at all on the incentive side?
Well,
I mean,
there is
I agree, let's say, that the incentive side is important, especially, and I think not important, it's essential to go public. But the way, let's say, how today these incentives work, let's say, is problematic, let's say, in the way it gets an unpredictable, let's say, cost structure. And in that sense, let's say the permissioned ones, let's say, have a much more controlled way of the cost. You know, let's say, what it will cost to do the transactions. So if somebody, let's say, in the academic can find out a way to do something about that, that would be marvelous. I mean, you get a Fields Medal, probably.
I think, you know, I think it also depends on what's the service that's being provided, and what is the customer expectation, right? And I think, you know, then you can start to think about what the incentives need to look like. Because if you look at an example of like helium, you know, I don't know if anybody's familiar with helium, but they sort of provide a low power network, and they compensate people. It's a, you know, you can buy the hardware, et cetera, to provide the service, and it runs on the helium network, and they get compensated in helium tokens. And that's okay, right? But that's not a robust enterprise network right now. And so, you know, there's ways to sort of make that business model work. I think it works very differently depending on the type of customer and application that you're thinking about, and then what the right incentive is, and if it makes sense to use a, you know, a currency to provide that incentive.
Great, thanks. Another question in the chat here went over to you. Should we be building trust models with reference to more formalized theories of trust from disciplines such as philosophy? There's been a great deal of thinking about what trust is in this discipline as one example.
Yes, of course. That if the people raise the question, have the pointer, that will be greatly appreciated, because when we get into this area, it's pretty subjective, and not as a very well defined as a security and all the others. So if there are some work being done already, especially there will be some quantitatively measurable, that would be great. I would like, I'm not sure, can find my email and pointing, that will be great. Thank you.
Raouf, did you want to comment on that at all?
In my opinion, I think that's the main that's the main added value that the blockchain brings, like to basically providing a root of trust, because of it is secure and it is immutable, and whatever goes into the blockchain, nobody can just alter it. Of course, we have to, like if say again, take the example of Bitcoin I mentioned before. In order for the blockchain to be secure, we have to trust that the miners will not really will not do something wrong, right? And that's basically the main message, or that I try to convey in my position statement, is that, and why it is working in Bitcoin, because we just don't need to trust them to be honest. We need to just trust them to be rational, because they're paid for for being honest, right? Hence the incentives, going back to the previous question, right? If we are able to engineer incentives that basically, incentivize, people to be honest, then we have our root of trust, and it's called the blockchain. That's exactly the main thing that the blockchain provides, a root of trust for all kinds of network applications. That should not be, by the way, added to the blockchain. And this is another misconception. Everybody is trying to put everything into the blockchain, supply chain into the blockchain, all kinds of things into the blockchain. I think that's what the blockchain is better at. I think when and others mention the scalability, the performance and issues with blockchains, I don't think it is meant for this kind of, 5G or 6G transactions that require very low latency. I think all of that can be done off chain. What we need to have happen in the blockchain is this whole thing about the security, the authentication, the identity management, and all these things that are very important, the naming and other things that are very important to all kinds of other networking applications. Yeah, so I think the blockchain provides a root of trust, and it can only be used as a remote coupled root of trust for traditional network protocols, traditional between quote unquote, and should have less hype surrounding putting apps or whole apps on the blockchain, supply chain on the blockchain, Uber on the blockchain, and so on and so forth.
But isn't also, let's say, one of the at least, let's say, on the public, like Bitcoin, it's essential that there is maybe only one of those, because if you would have, let's say, 1 million Bitcoin chains, then it becomes hard. Let's say which one is to trust. So and that is sort of secured, let's say, by if you find, let's say, a copy of Bitcoin on the street, it's probably only the single one, because the energy it would take to make another version is so immense that it's very unlikely that the one that you find on the street is just a fake one.
Yeah, I think that's, in my opinion, if you ask me, what is the actual the current gap or the challenge that is out there, is we don't have the ideal blockchain yet. We have several blockchains. And we can discuss how performant or how scalable they are. But I think we don't have the ideal blockchain that reconciles flexibility and performance with the extreme security and immutability that the blockchain requires.
Yeah, Raouf agree. I think that's the one is yet to design, not the Bitcoin or the blockchain exists today. They are not fit.
Thanks for that. We're up at the end of our time here. I see there's a couple more things in the chat. Vicky shared a document in there and some material. I want to thank everybody for their time and their presentations and the discussion. And Vicky, I think we have someone else coming up right away here, so I'll hand it back to you.